here's something to think about. What does the ocean have in common with violin music and a light bulb? Although they may seem completely unrelated, they actually share one important thing. They're all a wave. Hi, I'm Emily Harvey, a high school senior from Crown Point, Indiana, and today we're going to talk about waves. So what is a wave? A wave is a parcel of energy that moves through some kind of medium, which could be air, like in a sound wave or a light wave, or it could be water, just like in an ocean wave. There are two main types of waves. There's a longitudinal wave and a transverse wave. They both share one characteristic, which is the period. Period is the amount of time it takes for one wave to occur, just like a period in school is the amount of time it takes for one class to occur. So first we're going to start with a longitudinal wave. A longitudinal wave is typically drawn like this, and one example is a sound wave. In a longitudinal wave, the medium and the wave move in the same direction, which here is towards the ear. They have a compression, which is where the waves are closer together, and a rarefaction, which is where the waves are further apart. You can keep them separate by remembering that it's rare to find a wave in a rarefaction, just like it's rare to find a unicorn in real life. Is there any way to model a longitudinal wave? Well, actually there is, and you can do it yourself at home if you have a slinky. So I stretched the slinky out on the floor, and then I grabbed a handful in my left hand. When I let go, it creates those compressions and rarefactions that we talked about earlier. In this example, the slinky is the medium, and to show you that the medium moves in the same direction as the wave, I'm going to tie this blue pipe cleaner around one part of the slinky. As you can see, both the blue pipe cleaner and the wave itself both travel to the right side of the screen. This proves that the medium and the wave move in the same direction. Now that we've talked about longitudinal waves, let's move on to transverse waves. A transverse wave is usually drawn like this, and in a transverse wave, the medium moves at a 90-degree angle to the wave. So here, the wave is moving towards the right, but the medium would be moving up and down. A transverse wave has a crest, which is the highest point of the wave, and a trough, which is the lowest point of the wave. You can remember which is which by noticing that the trough is shaped like a U, kind of like a horse's trough. Can we model this kind of wave with a slinky? Of course we can. Let's go to the lab. I've got the slinky stretched out again, and I'm just going to move it sharply to the side to create a transverse wave. We can use the blue pipe cleaner again to tell the direction of the medium, which is the slinky. When we tie it around the slinky, we can see that the medium is moving up and down, or at a 90-degree angle to the movement of the wave, which is to the right. Alright guys, that's all. Thanks for watching!